Assalamualaikum. My name is Ahmadin bin Muhammad Fauzi, and today I'm going to explain the activity one: voltage, current, and power for different value of resistance. So, given that five resistance, which are 100, 200, 300, 400, and 500 ohms, then we have to calculate the power using the calculations given, and the simulated voltage, simulated current, and simulated power will taken the result by this simulation that I've made. Uh, so here's the simulation that I've made, which the resistance is 100, 200, 300, 400, and 500 ohm. So as you can see, there's the simulated voltage M, which is the current, and the power, which have been simulated from the circuit diagram. So that is all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin Muhammad Yazid with match number DE180161. So today I'm going to present regarding the activity 2 that I have been responsible to complete it. So the title for activity 2 is the electrical power measurement in an AC circuit with resistive load. So for the circuit arrangement, I'm going to follow this because on the instruction it stated that assemble the circuit based on figure 6.3. So for the circuit simulation, we are going to use, and I'm going to use the Proteus applications for the simulations. So let's proceed with the simulation. So this is the simulation on Proteus for the activity 2. So I already choose all the component. So we're going to assemble it. So this is the circuit arrangement, consists of AC voltage source, a voltmeter connected in parallel, and a wattmeter. So for the AC voltage source, we're going to set it by pressing the icon. So this is the amplitude based on the stated on the instructions. We need to set it on 100 volt for the V peak, and for the frequency, we're going to set it for 50 hertz. Other than that, we are going to set it as default. So for the wattmeter, we're going to use the phase. So this is all the default setting with display range for wattage. We can choose either. We're going to test it on apparent power or real power. So, but this we're going to use the real power. So we proceed with the simulations. So for the R1, the setting is for the 100 ohm. So this is the result of the simulation for activity 2. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim bin Saharuddin, and my matrix card number is CE180960. We proceed with the simulation to measure the electrical power measurement in an AC circuit with capacitive load. This is the circuit connection from the lab sheet that I have to simulate in Proteus. In this activity, I need to find the impedance, simulate apparent power, simulate real power, and to calculate the power factor. All the formula has been given from the lab sheet. So in Proteus, I designed for capacitive load measurement. I connect all the components like this. I use the AC circuit, AC voltmeter, wattmeter, RL, 100 ohm, and the variable of values for capacitor is in microfarad. First of all, for instance, for the first measurement, I need to measure between 100 resistive load and capacitive is 2 microfarad. if I run the simulation, the value showed 70.7 volt and the real power is 0.20. Then for the next value of capacitor value, I only change this value for 0.000004. As for microfarad, then I run again. The value for AC voltmeter is 70.7 volt. Meanwhile, the value for wattmeter increased to 0.78. So all the values are same, that I need to increase the value, the capacitor, into 4, 6 and 8, and the last one is 10 microfarad. All the procedure are same, and for 10 microfarad I got the value for wattmeter 4.50 watt. So that is the electrical measurement in the circuit for capacitive load. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Fazil. So I will present my part for lab 6 for this lab. So my part is activity 4, which consists of power measurement of resistor and the inductor. Okay, as you can see, this I have conducted the circuit input by using Proteus software. So this alternator. So this wattmeter. Okay, this resistor and this inductor. So by following the lab sheet, so I've been set the value of the alternator is 100 volt peak to an frequency of 50 Hz. So after that, I've set the value of resistor and inductor 1, which is L1, according to the lab sheet. So after that, I will change the value of inductor, and the R1 will be costed at 100 ohm. So the result for this lab is, as you can see, for in this slideshow. So for the load is costed at 100 ohm. For inductor value is different for different. There are 5 activity, so different value for different activity. So we can after that I calculate the impedance by using the formula at the lab sheet given by at the lab sheet. So simulated output power VA, simulated power watt. This by the simulated by the Proteus. So watt is you're using wattmeter, and VA simulated output power also using wattmeter. So after that I can calculate the power factor PF by simulated power divided by simulated output power. So that's all for me. Thank you.